On today's episode, we have Mark Chen, Senior Sustainability Engineer at Skanska, joining us. How you doing, man?
I'm good. Thanks for having me on the show. I'm excited. How are you guys doing?
Doing great. So this is your first podcast, right? First time on a podcast?
It is, and I'm a big time podcast listener. So I was excited when you guys reached out. I was like, oh, this is my chance.
This is my chance to stardom. Well, hopefully we don't set the bar too low, but I think this will be a good one. So before we kick it off, I'd really like to just kind of understand who are you, what do you do? And then really kind of what has guided you onto this path of sustainability as a career path?
Yeah, so starting from where I'm from and how I got to where I'm at today, Southern California native. I grew up in the Pasadena area. And I think growing up in LA gave me this kind of visceral experience around sustainability, just with air quality and drought and water conservation measures. So from an early age, I really had this kind of value ingrained about it because I was, seeing it and experiencing it almost on a daily basis sometimes. So from there, I went to the University of Washington here in Seattle, got my degree in civil engineering. And for a long time, I wanted to be a structural engineer. I had a few internships and kind of learned more about myself and realized, maybe structural engineering wasn't exactly the route I wanted to take. And from there, I decided, construction management and general contracting seemed more of my cup of tea. So I started with a large commercial general contractor right out of college, worked in their pre-construction group, and also spent some time as a project engineer on some TI renovations. So really got my feet wet in the whole construction industry and how things operate there. And really the whole time, my entire experience working for a general contractor, I would either be working on something in pre-construction or would be out in the field on site as a project engineer. And I would always, say to myself, like, there are better ways to do this. There are so many things that could be done to kind of improve the way construction companies operate on a sustainability level. And so I really got passionate about it because of that, because I saw this opportunity, this tangible opportunity of, all these waste dumpsters being hauled off site, all this fuel being burned on site for our construction activity. So I got really involved with different sustainability groups, organizations outside of the company. Eventually I met Stacy Smedley, who is our Skanska Director of Sustainability, and she reached out one day, and there was a job opening at Skanska to do sustainability full time, which by then I had realized, that's kind of where I wanted my career path to go because I had developed a real passion for it. So that's kind of how I arrived where I'm at now with Skanska, with our sustainability team here in Seattle. And yeah, I guess the rest is history now.
Mark, I think it's interesting. Oh, go ahead.
I was going to say, Mark, you talking about being on the construction site and seeing all of the waste that just gets built up. It really just struck a chord with me because at my school, we had to do like a semester long internship and move away and, find out what it's like to work full time on a construction site. And one of my primary responsibilities was, waste management on the job via picking up trash and placing it in the dumpster. And I was amazed by how much waste there was on the construction site and how, the last job I was on, we had 2 full dumpsters a day getting hauled off, probably to a landfill. None of that material was getting reused. It was just being wasted. And, that's kind of what led me to, try to research how recycling in the industry, would be really advantageous. I know like through methods like prefabrication, they're already kind of starting to do that, or at least being more efficient with material usage. But, it's something that really there's not a spotlight on it quite yet. And when I was researching this topic on embodied carbon, I wasn't even thinking about, the full life cycle of materials and the amount of carbon that gets produced just by trucks driving that, material to the job site.
Yeah, absolutely. And the other thing that I always observed was a lot of the waste that ends up in our dumpsters is probably usable for someone. You think about all the dimensional lumber and wood waste that ends up in construction dumpsters. A lot of that can be clean, a 6-foot long 2x4. Someone out there could probably use that, whether it's a low income housing group or just someone trying to buy lumber, which recently has been astronomical in price for their home improvement. So yeah, number one is trying to reduce waste, and then two is trying to find the best kind of end market for that waste stream. There's absolutely so much you can do with that also overlaps with community and things outside of just sustainability and landfill diversion.
I think it's an interesting topic, and I know Jackson's been excited because he's talked about amount of waste getting pulled off a job site in multiple episodes. And so it kind of is the culmination here in this episode. But, and before we kind of dive into this idea of like what a embodied carbon is or whatnot, I do think that it's interesting you mentioned somebody can use that material, because there's a building here in Atlanta on Georgia Tech's campus that I think it was a Green Globe project. I don't know if Skanska was involved in that one or not, but they partnered with a local organization that all they do is collect waste and material for recycling. And it's like this huge warehouse in downtown Atlanta that you could go through. And, there's just doors and stairs, everything you can imagine. And it's interesting to see how people are using that early on in the design phase.
So you're teeing me up perfectly for a little Skanska plug, shameless plug. But we just finished the Candida building on the Georgia Tech campus.
That's it.
So Jimmy Mitchell, shout out Jimmy with our Atlanta team, Skanska Atlanta team. He actually was one of the founders of that reuse center. So really cool story there. And then I know for the floor diaphragm framing, Jimmy worked with some local organizations to source, I think it was salvaged lumber from, it was a film studio. They just had a bunch of clean lumber that was used for, making sets. And they basically used that lumber as a spacer in the floor diaphragm. So they basically got, I don't want to say free material, but, this reused material incorporated into the structure of the building. And they also hired, this is the part of the story that I don't want to speak too much on because I don't know a ton about it, but I know they hired some, I can't remember if it was at-risk labor or kind of low-income folks from the Atlanta area to actually put these floor panels together. So it had a really great story all the way across the board, whether it was sustainability or community or equity, all of that good stuff. So
it's a cool building. I went to Georgia Tech. So when I was on campus and I toured it when it opened, and I mean, it's amazing just in general. And then like all of the, different points that they had to get in order to achieve what they were going after. And then when I started reading more about how they did the recyclable material, it all started to click. And, it really touched, because I think even like Lord Eck was one of the architects that worked on it. And, there was a lot of effort that went into the design up front to take that challenge on, coordinating obviously with Skanska to make it happen. But it's a really cool project. And is worth, anyone that comes to Atlanta should absolutely go see it, because there's so much inside. And as you kind of walk through it, you almost learn a little bit about the different stages of what they were trying to achieve, which I thought was a pretty nice touch.
Mark, you know how I know you listen to a lot of podcasts? You said shameless plug. And also, I'm going to take it a step further. Mark, you are now a friend of the show. Or a friend of the pod, I mean. So I do. Yeah. So I do want to take it a step back for the people who are hearing us talk about this, who are saying, what is embodied carbon?
Yeah,
what is it?
Absolutely. So embodied carbon is defined as all of the energy and specifically carbon emissions associated with the manufacturing of a particular material. So like concrete as an example, all of the emissions associated with extracting the raw material from the earth, so like limestone for cement, transporting that material to like a cement manufacturing plant, the emissions associated with turning that limestone into cement, all the energy and the actual chemical reaction that's associated with turning limestone into cement, and then also getting that cement to the concrete ready mix plant, everything that goes into actually mixing all the concrete with the cement, the aggregate, the water, any admixtures, and then also getting that concrete to our job sites, and then also installing that concrete, like pouring concrete, placing the concrete for whatever application it's being used for. So that kind of encompasses embodied carbon. It's really the upfront emissions associated with getting a product or material installed on one of our many construction sites.
You know, I'm curious to get your thoughts on this as we start to talk about how we can actually reduce it. But I read when I was doing some research that as an industry as a whole, we've focused a lot. Well, what amount of time we have spent on climate change has been more on the operational energy consumption. So heating and, you know, daylighting, cooling, water consumption, all of that. But it was saying that there's been a less of an emphasis on the embodied carbon part until maybe recently. Do you feel like that's true?
Yeah, definitely. So again, a shout out to Stacy, our director of sustainability. She was doing studies with University of Washington Carbon Leadership Forum on this, years ago. And the reason, to your point, why it became such an important conversation was because, here in Seattle, a lot of our electricity comes from hydro, so it's very clean. We don't have a lot of emissions associated with, burning kilowatt hours in the Seattle area. And because of that, when you're actually looking at the full life cycle of a building and incorporating the embodied carbon, Stacy and the UW group were finding that there's actually a huge proportion of the building's total emissions coming from the embodied carbon side of it, up to like when you're incorporating the entire life cycle over like a 30-year time window, it was still like 80% of the emissions were coming from the embodied carbon and only 20% were coming from your operational emissions. So that's what made the light bulb go off in a lot of people's heads, especially with clients we work with here in the Washington market who have a lot of value around, taking responsibility for their carbon emissions. So that's kind of the backstory and why people are really starting to pay attention to it now. It was kind of a blind spot for the industry for a long time.
So I was reading, and it may have actually been, it was written by Skanska, so it may have been the director of sustainability, but it was talking about kind of ways that we can reduce embodied carbon, and it lists a bunch of stuff. And I'd like to kind of go through all these different ways, because I'm sure if people may be listening or, they're interested in climate change, sustainability, but there's always like how do I get started? It always feels overwhelming. You kind of get the sense of like, I by myself can't change stuff, all of those type of things that people run into. So when we talk about reducing embodied carbon, where do we start? Like, what's the first thing? I know there's like a laundry list of stuff we can go through, but what is the first thing we want to focus on?
So I think understanding the basics is definitely the starting point. So we just talked about what embodied carbon is generally. So of course, that's the most important first step. I think also understanding that there are a number of different ways to handle embodied carbon. There's no, this is how you need to do it. This is the only way you need to do it. There are lots of different tools and methodologies out there that can help address embodied carbon. I will say, again, just from the Skanska side, the EC3 tool, the Embodied Carbon and Construction Calculator tool, is a tool that we are using currently most often to address embodied carbon. It was a tool that was started by Skanska and Stacy Smedley with our Seattle office in partnership with the University of Washington, Microsoft, and plenty of other industry partners. And so that's a great starting point. And from there, it's really understanding kind of how EC3 works, what its limitations are, and where its strengths are. And then working with your team, if you're in a project team trying to deliver a given project, really getting people educated around, again, what embodied carbon is, what the EC3 tool is, how it can be used throughout the design and procurement and construction process to lower embodied carbon.
Piggybacking off of that same article that Chris was mentioning, at the very end, it mentioned that Skanska's mission right now is to achieve net zero carbon emissions by 2045. Can you speak a little on that?
Yes. So, I think that commitment is, it's ambitious, obviously. It's very, very ambitious. And so that 2045 carbon neutrality commitment not only includes Skanska's own direct scope 1 and 2 emissions, if we're talking geeky emissions accounting, carbon emissions accounting talk, but it also includes our, quote unquote value chain. So that includes our supply chain, which also incorporates our embodied carbon. So even if this was just Skanska's own direct emissions, it would be an ambitious target. But now that we're also including the supply chain and the embodied carbon, it is a big time effort for us here at Skanska to get to that point. And the scary part is 2045, really isn't that
far away.
We have an interim 2030 commitment of a 50% reduction just for our direct emissions, doesn't include supply chain or embodied carbon. And, here internally, we're looking at the calendar and going, holy cow, this is 9 years away. So lots of work to be done. But I also think, again, with the EC3 tool, the power of the EC3 tool, which I'm sure we'll get into some of the details on this podcast in a little bit, but it gives the general public visibility into the emissions of different companies and manufacturers that we're using. So with that transparency, the hope is that it will drive some market transformation, because all of a sudden, if I'm manufacturer A and I realize that folks like Skanska and other industry partners are realizing that manufacturer B, my competitor, can provide the same product for a much lower carbon footprint, that becomes a competitive advantage for manufacturer B. So for me as manufacturer A, I'm going to start looking at my operations more closely. And that's kind of where the market transformation part of it comes into play, or at least that's the intent. Because we're not going to get to that 2045 goal unless we have the entire industry brought in. There's just no way it's going to happen without, again, the hashtag market transformation.
It kind of aligns to, I was looking up, the World Green Building Council has sort of set out a similar statement where it was 2030, they were going to it was 40% less. And then 2050 was completely net neutrality. But it is kind of crazy because, I remember we had conversations a couple of years ago and talking about like the architecture 2030 challenge and all these things. It seems so far away, and yet here we are. And regardless of opinions, things are getting more intense. We're recording this right as there's like a historical hurricane hitting this, Louisiana, and we're dealing with wildfires out west. And so it's kind of getting to that tipping point of like, it's not a matter of do we want to, but it is pretty critical. So I appreciate y'all's intent to, try to hit those. So as other companies, so we say, okay, hey, we want to reduce carbon emissions, and we recognize that we have these tools, say like EC3, and it seems that obviously so much is dependent on the material. So what are we doing, or what are you seeing firms doing? Because this goes all the way down to the design at the very beginning, because schematic design. We're designing projects with materials, a lot of times not even engaging you as the contractor yet. What are things we need to be thinking about on the design side to help sort of make our way to what would ultimately be reduced carbon?
Yeah, so someone made this kind of analogy a while back, and it always stuck with me. But right now with embodied carbon, it feels like we're in the turn the lights off phase of where we were at with energy efficiency maybe a decade or two ago, where we're just starting to understand the data and the methodology to actually quantify, even just quantify embodied carbon. So right now, a lot of the focus, the low-hanging fruit, is just kind of the intuitive stuff, similar to, if you think about energy efficiency, like one of the things you can do is just turn off the light when you don't need to. It's kind of the same concept with embodied carbon. How can we design, or how can, our structural engineers and architects design to reduce just the amount of material that we're using on a given project? That's probably the most elementary and intuitive step you can take. On our end with Skanska, just being a general contractor, we're looking for ways to reduce the cement content of our mixes, be more efficient with our materials where we can help it. Because really just like waste, energy, water, whatever it might be, the best first step is to just reduce your impact. Reducing the amount of material resources that you're using is always the most sustainable strategy. So that's probably the best starting point. And from there, it kind of goes into, once you get past that point of the turn the lights off, that's where you start to look at different products and different innovations and technologies that are hitting the market currently that can further drive down that reduction. But there are some, very basic things you can do to lower your embodied carbon right off the bat.
I can imagine how, like, again, my background being architecture, when I think about on the design side, we've had episodes, in the industry, we're seeing computational design pop up a lot. And a lot of people are using it for, just whatever they need to use it for. But something I don't see using it a lot is thinking of it from an aspect of how can we use it to potentially help us guide to reduce material. It kind of starts to play on the idea of using these type of technologies in manufacturing when we're doing like additive or subtractive type of manufacturing, and seeing how much material can we take away from something. So I'd be curious to see if it's something that a lot of our peers on the design side can start to use the tools that we already have in place to look at ways of reducing the material ahead of time. Because I don't know if a lot of firms, or unless they're going for LEED or the Green Globe or whatever, I'm not sure that's always the forefront. It's more aesthetics, and then there obviously is cost. But sometimes I think the carbon may be what gets missed.
Yeah, and I think even outside of just tools, there's some system level decisions early on in design that can be made around reducing your overall material quantities. So mass timber feels like this hot topic right now. And we could do a whole another podcast around mass timber and the carbon pros and cons with mass timber. But even like take all of the, talk around biogenic carbon, the carbon sequestered in wood, and the benefits of that over concrete and steel. I think I've seen case studies where, using mass timber, obviously it's a beautiful product. You want to showcase it. And if you can achieve this with your project, a lot of the times your mass timber structure is going to be open structure. You're not going to want to wrap your columns in drywall. You're not going to want to have all these fancy ceiling finishes because you want to expose that beautiful wood product. And so that's one thing that can also result in, it's kind of a secondary benefit, but because of that, you're reducing all these other finishes that you would otherwise be putting in your building if it was concrete or steel. So that's just an example off the top of my head. Obviously using the EC3 tool is another way to quantify those kinds of decisions. But of course, there's other tools out there like Tally. I know the Athena Impact Estimator is another, I believe, free tool that you can use. But that's where it gets complicated. There's so many different materials that go into a building. There are literally millions of different permutations, if you want to call it that, of what you can do to kind of reduce your overall material quantities in a building.
So where does how does the EC3 tool come into play? Is it coming into play on the design side early front, or is it you as the contractor are using it after it's been designed? I mean, where does that start to fall in?
So ideally, the EC3 tool is really geared around kind of mid to late design. So once you're in DDs and CDs, and then definitely once you're in the procurement phase, the buyout phase, and then the construction phase. And so I guess for the listeners too, just so everyone knows, the EC3 tool is very much, I don't want to say limited, but the boundaries are drawn very distinctly. EC3 only includes your raw material extraction through manufacturing emissions and nothing else. So if you want to take into account a full life cycle analysis, the EC3 tool is not the tool to use, because it only accounts for those early upfront emissions. So, all that being said, it really is the ideal use of the EC3 tool is in design, but also once your contractor is engaged, ideally. Because a lot of the power of EC3 comes at the contractor level, when we're going to buy, different bid packages out.
So in the past, when BIM started to come to the industry, adoption didn't really happen until owners started requiring it. And it sounds like for, this mission to reduce the embodied carbon, the onus is on the designers as well as the contractors who are actually building the building. Who do you think is going to be the primary driver behind, getting to net zero?
Yeah, I think you hit it on the head. I think the owners, like with almost everything, drive a lot of the change. Not to say that the general contractor can't create that movement, or the architect or engineer or consultants, but I think on the ownership side, having companies and public entities that value carbon emissions and reducing carbon emissions definitely kind of mobilizes the rest of the industry to follow suit. I also think policy will be a big part of driving the change that we need. I know in California, there's already legislation around embodied carbon through the Buy Clean California Act. So just from that alone, there's going to be a lot of companies out there trying to figure out what this embodied carbon thing is and how they expect to comply with California legislation on public projects in the future.
What do you think are some, immediate steps that people can take today on their job site to try to reduce their carbon footprint?
I would say the first step would be education. So educating the full project team on what it is, why it's important, especially if it's a project team that's going for any kind of LEED certification, or if it's an owner that values the energy efficiency of their building. Because if you really do care about just the end goal around carbon emissions, then embodied carbon definitely needs to be part of the equation. But outside of that, so because the education part of it right now, just with how kind of new the concept is, it's probably the most important step. Because I'm not saying it's a bad thing, it's actually a good thing, but when we talk to a lot of our trade partners, a lot of our suppliers, even some of our, design teams about embodied carbon, honestly, more often than not, we kind of get the deer in the headlights look, because no one's really, there's one LEED pilot credit around it, but it's really not fully integrated into LEED. It's just not something a lot of people have heard of. So again, once you get through that education phase, I think creating some tangible goals for the project is really important, so that everyone universally has some kind of goal to work towards. And outside of that, using the tools that we have now, like the EC3 tool, it's a public open source tool. Anybody can sign up for an account and access the data within the tool right now. And really leveraging the data to at least understand where we're at and see where, you can turn the lights off, like we kind of alluded to earlier. Because there's always low hanging fruit. It's just a matter of finding where that fruit is.
Yeah, some of the things that come to mind are, start putting recycling bins at the job site, because, people eat lunch at the job site. There's plastic water bottles going in the same dumpster where, drywall pieces are going. And another thing is, a cool idea would be maybe a solar powered charging station for tools, like things like that. I think would be pretty cool.
That's an interesting one that you brought up, the food thing, because I was reading, it may seem small, but one of the things that there's a lot of waste around is everyone eats lunch, everyone has their water bottles, and there's a lot of people on the job site, and it goes on for an extended period of time. And it actually specifically called out in an article talking about embodied carbon was the individual's lunch waste and accounting for that. So it seems like the education point, I think, makes a lot of sense, because like if I'm the designer, I'm choosing a certain material, I could try to reduce it. But something else that comes up is, based on the material I choose, there's embodied carbon in the transportation of it, is it not? So, can you speak to, I guess it's not just the material transportation, but even, I guess in some places, the transportation of the workers. How does transportation start to have a play into reducing embodied carbon?
Yeah, that's a great question. So, like I mentioned with EC3, the boundaries are set so that actually currently that transportation from like the manufacturing plant or the fabrication facility to the job site is not included in EC3 right now. I know the team is working on that and having a plugin to incorporate that, but it's not part of the publicly accessible tool right now. So this is another part of what Skanska has been working on for the last couple years, because really it's come down to us tracking this with all of our trade partners, because for the most part, a lot of our work is subcontracted. So all of our material deliveries to site, all that transportation that you just talked about, craft workers, really anything to do with vehicles coming onto our job sites, the lion's share of all those emissions are coming from our subcontracted work. So we've created kind of on a few projects with clients that were on board with doing this, we've created a methodology to track that on a monthly basis. And I think, if you're a general contractor or any kind of construction company out there and want to get involved and start tracking your transportation emissions, my biggest, I guess, piece of advice is that there is probably data out there that is already being tracked that can help you get that information. So we've developed these different reporting cadences with our subs where they'll send us their monthly list of deliveries. We've created this spreadsheet that basically we just copy and paste that data in. It does the calculations and out pops our carbon emissions footprint. But there are some trades who, if you think about our structural steel fabricator, whoever it might be, there's lots of deliveries that might be coming to site in a given month. So we leverage things that we were already tracking internally. Like for lots of our projects, we have, just for logistics and for our superintendents, they're already tracking scheduled deliveries to the job site, because we need to do that. We can't have 5 delivery trucks showing up at once, bottlenecking the entire, construction entrance. So on lots of our larger jobs, we have that kind of regimented and scheduled delivery process. So we've been able to just pull from that kind of data source that our superintendents are keeping to then create the roadmap for the reporting that we need to track material deliveries. And so again, it's kind of all been in-house developed calculations and methodologies to quantify those emissions and then look at opportunities where we can see reductions. But it has been really, really fascinating to track where our materials are even coming from, because most people don't even think about it. A lot of our structural steel, what we found out is a lot of the big structural steel mills are all based in the Midwest or the Southeast, which when you actually think about it, isn't that surprising. So when you think about getting structural steel to a job site here in Washington, there's a lot of travel distance involved with that. So just on that level, it's been really interesting to take a closer look at where materials are coming from, how far are they coming to the job from, what mode of transportation are they coming from, what's the fuel that's being used by the trucks or whatever vehicle is transporting to the job site. yeah, there's a whole another kind of art form and science behind tracking the transportation side of it.
Yeah, I was curious because coming from the subcontractor perspective, and my last project was a downtown one. So deliveries, it had to be scheduled out and it had to happen in a certain amount of time because you were using the crane and things like that. But it seemed like no matter what we were getting, whether it be a fan, air handling unit, a rack of pipe, it was a different delivery company. And the truck would sit there for, sometimes 30 minutes to an hour just idling, you know, while we're trying to get the material out. And it's just all that wasted energy right there. And another thing, another task I had on my internship was getting gas for all of our pieces of equipment. So are you seeing equipment companies start to try to adopt, maybe like electrical means for their equipment rather than gas, or maybe alternative energy resources?
Yeah, absolutely. So when it comes to equipment fuel burn on site, yes, we've seen manufacturers and kind of the market starting to, I mean, just like, the vehicle market, the trendy topic now is electrification. So we have seen new models coming onto the market that are fully electrified, telehandler forklifts, things like that. And we've, like our Skanska yard, which maintains a lot of our own Skanska equipment. We've looked at electrified equipment as of even this past year. It feels like the battery technology is right on the cusp, but not quite where we need it. Because the last thing we can afford to do is roll out a big electrified mobile crane that can only get 5 hours of work out of the 8-hour workday before it needs to be recharged. So we need to make sure the productivity can be there, the battery storage can be there before we really make the investment into those electrified engines and electrified pieces of equipment. So what we have been looking at in the interim while we wait for kind of the market to shift and for the technology to scale, there are alternative fuels out there. Most people have probably heard of biodiesel, but there is another different fuel out on the market called renewable diesel. It meets the same ASTM specification as your standard petroleum diesel, but it has great emissions benefits. On a tailpipe emissions factor, it's over a 90% reduction compared with standard diesel. So we've been really hot on the trail for that fuel type for a lot of our equipment. We've been using it in a lot of our machines in our LA market, our Skanska Civil Los Angeles projects. We've also started to look at it here in Washington, Oregon, kind of in the West Coast for the most part. So that's kind of been our stepping stone to one day get to fully electrified job sites, is looking at cleaner fuels outside of your standard diesel or gas. And the other great benefit about renewable diesel too is that we don't have to swap any of our equipment. We don't have to make any modifications to the engine. It's a drop-in ready fuel. Unlike biodiesel, if you start to get above like a 20% biodiesel blend, you start to affect engine performance, warranty, all that kind of stuff. And on top of that, the even better part about renewable diesel for our maintenance teams is that because it's supposed to burn cleaner, you spend less time actually cleaning out the diesel particulate filters. You have less of those regen cycles for your engines. So all in all, that fuel's been kind of I guess the closest thing to like a silver bullet for us for dramatic emissions reduction for not that much effort.
Do you see robotics, autonomous vehicle type things aiding in the reduction on the fuel cost, or do you think that would actually drive it up?
Oh, that is a great question, and I'm really torn on my answer because I think robotics could solve a lot of our problems and help with a lot of the sustainability goals that we have. At the same time, having been on job sites before and worked with all of our trade partners, I know there's a hesitancy to go that route for the most part, because that's job security for a lot of our craft folk who we especially now absolutely need more of to help us build. So I guess it depends on the application. Yeah, it's hard to have a blanket response, because there's so many different ways you could use robotics, and I just think there's probably lots of intended benefits, but maybe some unintended consequences too, that I don't know what I don't know.
And that's what I was actually wondering about, would be if you imagine, like, if we had a job site where there's 10 folks that are doing things, and then we're going to replace, replace sounds harsh, but 5 of them become a robot does those tasks. That's now 5 electrical things that are consuming some type of fuel that didn't exist before. So I'd be curious if, there's this big push for automation and robotics and all that stuff. Are we going to see an influx in our carbon emissions in an attempt to automate and increase our productivity?
That's another great question that I've actually never really thought about before. I wish I had a good answer, but I don't.
I just made it up.
Yeah, I don't even know what like if we had a robotic, I know some of our like drywall partners have started using robotic like layout machines where they can lay out walls with a robot, but I have no idea what the energy usage for a full day of work for one of those robots is. So I'll have to chew on that one. I don't know.
Are there any emerging materials other than mass timber that excite you going forward?
Yeah, so concrete is such an integral part of infrastructure and society. It's going to be near impossible, I think, to ever get away from concrete completely. So there are some really interesting technologies with concrete that are, we've been doing some research around it. Lots of other companies have been doing research around it, mainly around cement replacement. So there are things like ground glass pozzolan. So basically you can take waste glass, grind it up to a certain specification standard, and that can actually serve as a replacement to cement. Obviously, that has a much lower carbon footprint than mining limestone from the earth and turning that into cement. So that's a really interesting one that I'm excited about. I'm trying to think what else. Just with some of our other materials, I've heard, it seems like everything progressive seems to start in Europe, but I've heard of hydrogen powered steel mills that can manufacture steel with 0 emissions. And I think there is a company in the US that I talked to them a while ago. It sounded like they weren't going to be operational until 2025. So we're a little bit a ways out from getting there, but there are companies with steel specifically that are looking into technologies that can help really drastically lower the embodied carbon of steel production. Outside of that, I know there are some like cellulose bio-based insulation products that have a lot of great benefits over your standard plastic-based or mineral wool-based insulation. But again, I just think it seems like that's right now more geared towards the single family residential market. It hasn't quite scaled to the commercial market. Yeah, lots of interesting products. There's carpet products now that have a near carbon neutral carpet backing. Some really interesting stuff going on in the manufacturing world around this. But again, a lot of it has to do with, is it scalable so that we, Skanska, or another large project could actually source it on, $500 or $500, $500 million project, because that's where the big impact is.
And I would hope as time goes on, just like anything, the cost to generate goes down, the ability to mass produce and mass customize goes up. And like you said, it really does take the whole supply chain, because I mean, the building manufacturers, those plants are just as important. I mean, no matter what you do, a lot depends on what they do and how they transport the materials and how they create the materials. And so it does seem like education seems to be probably the best way as we kind of wrap up. And I think you kind of alluded to it, somebody wanted to start their sustainability journey today, what's the first thing they should do?
They should reach out to Skanska and make sure Skanska's hired for any project that they're doing.
I like it.
Just kidding. There's so many different avenues that I'm going through in my head right now. I think, and this is one thing that we've been talking about internally here in the Washington office, but survey your employees and your peers and see what matters to them. Because like we just talked about, one person can't change the market or change the way a company operates. Having your team or your company as a whole bought in is what will create change. So, like even for us in the Washington office, we sent out a survey to our entire office staff, and just asked them, like, between climate change, energy efficiency, waste, water, ecological preservation, like what matters to you? Like sustainability is there's so much that falls under the umbrella of sustainability that if you try and address all of it, you're just going to burn out. And so when it comes to, starting like within your own company, just understanding what your peers care about is kind of what will help you, I think, dictate what you focus on. So for us, like our staff, a lot of our staff here in the Washington office, a lot of them said climate change was what mattered most to them. So now everything we're doing, not everything, but a lot of what we're doing is centered around that, because we want our employees to be engaged with it. We want our employees to feel like that they have a voice in all this, because that's another part of the whole discussion, is that I think we need to have everyone's voice heard throughout the process in order to really change the attitude and the paradigm.
I think it's a great first step. Mark, we've really appreciated you joining us for this. It's been fun.
Yeah, likewise. Thanks for having me on.
Thank you, Mark.
Absolutely. I'll stop the recording.